Today we're looking at vector equation of a curve. So our learning intention is to gain the knowledge in expressing a curve in 3D space. We'll be successful if we can create parametric equations. Express a 3D vector in forms of x being the function of t, y being the function g of t, and z being the function h of t. And then recall and calculate the equation of a sphere using x squared plus y squared plus z squared equaling r squared. Okay. Right. So we want to try to graph, and hopefully in this course we won't be graphing that much, but I will also show you how to use GeoGealgebra to graph this. So let's want to try to graph the curve represented by 1, t, and t squared for the domain of 0, x, and 5 to 5. So what I do is I create a table. So this is my f of x, this is my what x would be, this is my g of t, which is what y would be, and h of t, which will be z. So t is going to be 0, 1, 2, 3, 4, and 5. So x is always 1. The y value is what t is. So when t is 0, it's going to be 0, 1, 2, 3, 4, 5. And then my z value is t squared. Okay. So trying to plot points. Okay, so we're going to go, the first point, we're going to go down to x equals to 1. So remember that the 3D space has x coming out this way, y that way, and z going straight up. So if I have, the first point is 1, that's where x is, y is 0, yeah, so I stay at 0, and z is 0, so I stay here. The next point is 1, 1, 1. So I go 1, then I go up to y equals 1, but then I need to go up to when z equals 1. My next point is 1, 2, 4. So 1, 2, 4. I then have 1, 3, 9. So 1, 3, 9. I have 1, 4, and 16. And then I'll have 1, 5, and 25. So what it looks like is a parabola going up the z-plane. Okay, so using GeoGealgebra, I'll just cover these ones out first. What we want you to have this 3D option, all you need to do is you go into your view and you click the 3D graphics. What you normally would see is the 2D graphics. Which is your normal number plane, right? So if I type in here, if I type in x plus 3, sorry. Right, we get this number line in the 2D. It's not showing us in the 3D dimension. That's okay. But we're just going to close this. We just want the 3D anyway. Okay. All right. So to write something like this equation, what we need to do is we need to write it in parametric form. Okay, so I'm going to call, going to delete that. So we want to write, maybe I'll say U equals, and I'm doing it in the input bar down here. I'm going 1, t, t squared. And if you use t as a parameter, it can figure that one out for you. And there you see, so we've got x coming out here, y coming there, and there's your z plane. Now you can move it around so you can look at it in 3D options. Okay, so it's sometimes very difficult to draw these 3D graphs, so GeoGebra will help you with that. Okay, now next example, we want to find the center and radius of this circle. Now recall, in the 2 dimensions, x minus a all squared plus y minus b all squared equals r squared is a circle with a center of a and b and a radius of r. We're going to basically do the same with this one. We obviously need to complete the square. So 6 divided by 2 is 3, square that is 9. 2 divided by 2 is 1, square that is 1. So I'll get x minus 2 squared, y minus 3 squared, z plus 1 squared, 10, 21, 25. So I have a sphere with center 2, 3, and -1, and a radius of 5 units. Okay. Here's another example. So we have 2 spheres. The spheres with equation x plus 2 all squared plus y plus 3 all squared plus z minus 4 all squared equals 16. So we've got a sphere 1. We have a center at -2, -3, 4, and a radius of 4 units. In sphere 2, we have a center of -2, -3, -2, and a radius of 5. Now they intersect, and we want to find where the center and the radius of this circle is. So in GeoGebra, I have these 2 circles. Yep. And we want to find where they intersect. Well, I know that they share the same x and y values. Okay. The difference in their z value is 4 and -2. All right. So okay, and this sphere has 4 units radius, and this one will have 5 unit radius. So what I really want to do I want to actually find the angle between the center joining the line and the 5 radius line. Okay. Okay. So what I'm trying to find is I'm going to find this angle here. Okay. So they're using cosine rule. So we get, because we want to find, that's 6 units long. So using these 3 measurements, we want to find what theta is. So we get 4 squared equals 5 squared plus 6 squared minus 2 lots of 5 and 6 cos theta. So cos theta is 25 plus 36 minus 16 over 2 lots of 30. So we get 45 over 60, which is 3/4. Okay. So now that we found that, we can find what the radius is of our new circle. The radius of the new circle. And that's this R here. Okay. So R, or sine theta, is going to be R over 5. And we know what theta is because it is going to be and times it by 5. So that's what R is. And working that out to be, I worked that out to be R equals 5√7 on 4. Okay, so that's what R is. So the distance between the circles is going to be that unit there. Let's call it Z2. So cos theta would be, or you could just use Pythagoras. Five squared minus 5√7 over 4 squared. So Z2 works out to be 15 over 4. So therefore the centre of the new circle is still going to be -2, -3. Now it's going to be 15/4. Yeah. And the radius is 5√7/4 units. Okay. And using GeoGebra, you will see that circle there. And if you're looking from above, you can see that it's concentric circles, even from below. Yeah. And you can keep moving around. So if you want to see it from view in front of the x-axis, you just click on the x-axis. If you want to look at in front of the y-axis, it'll rotate, or even across the z-axis, and it'll just change it for you. Okay, that's it. Good luck.